Hello everyone and welcome! Christmas must have come early because Llama 3 is finally out. Well, it's been out for a month and a half actually, but let's ignore that for now. In this video, I'm going to quickly go over what Llama 3 is, what's waiting us next, and how good or bad the newest models are. Let's start with their model details in Hugging Face.
Meta developed and released the Llama 3 family of large language models, a collection of pre-trained and instruction-tuned generative text models in 8 and 70 billion sizes. The Llama 3 instruction models are optimized for dialogue use cases and outperform many of the available open-source chat models on common industry benchmarks. Further, in developing these models, we took great care to optimize helpfulness and safety.
One thing super interesting here is that the models have been trained on 15 trillion tokens. A number human minds can't really comprehend. According to my very crude calculations, it's around a whopping 60 terabytes of data. This is absolutely incredible considering how Mr. Tiny was trained only on 8 trillion tokens and Llama 2 7 billion was trained only on 2 trillion tokens. I'm using the word only here with a quote-unquote since these numbers are anything but small. You might wonder though, what's the difference? Well, simply put, the more the better. Yes, data quality is very important, but quantity is still the king because it's easier to have. However, there is this thing called chinchilla coefficient. According to this scaling law, there's an optimal amount of data and anything after that just returns diminished returns. Although, this doesn't mean zero or negative returns, so it seems like models still don't converge past their chinchilla thingy and we might be underestimating these transformers models. According to Meta, even the 8 billion model was still learning after 15 trillion tokens. We honestly don't know how far they can go, but there might be some issues with that overtraining as well. I'm also going to talk about that briefly. Moving on, Meta team also released instruction-tuned models as well. We need to download those since we don't usually use the base versions. These instruction tunes from Meta are quite good, and many recent fine-tunes haven't reached this level yet. The models feel very human-like with witty and surprising answers. Although, let me mention the hideous template Llama 3 Instruct is using. To my knowledge, many big inference software like Ubabuga, Llama, and CodeLlama have already implemented this template, so you probably won't even have to think about it most of the time. We again have many quantization options to choose from. In this video, I'm going to mainly focus on the 8 billion model and Llama CPP. Just around a week ago, GGF coins were broken due to a few reasons. As mentioned, Meta AI team decided to use this freak template with 2 end-of-sentence tokens and multiple other special tokens. Nevertheless, we now have sort of working quants, but as of 5th of May, there still are bugs in the Llama CPP that causes various issues and it's still a work in progress. Now let me talk about the other strange issues with this state-of-the-art model. For some reason, quantization affects Llama 3 series more than any other model. If you wanna check the perplexity and KLD stats, you can stop the video here. Both KLD and PPS should be as low as possible. However, in this graph, Llama 3 8 billion models get significantly worse with quantization. We don't know exactly why, but one of the theories is that models are super saturated since they were trained with 15 trillion tokens. So, even incredibly small values that are lost in the quantization might actually be important for the model. You should look for a recent quant on Hugging Face because there has been at least half a dozen bug fixes and more will definitely come. For example, recently, an issue with the tokenizer was fixed. Now, there are some things Llama 3 is strong in. Of course, it's free without any limitations and mostly uncensored. You can fine-tune for your needs, change samplers, and securely use for personal documents. You don't have to deal with APIs, bills, and monthly subscriptions. All that said, let's run Llama 3's 8 billion and compare it against the free ChatGPT. Let's open CodeCPP. You can download it from GitHub freely for Windows and Linux. It's portable and you don't have to install anything. The only caveat is that you have to use GGF. I have enough VRAM to run Q8, so let's go with that. You can run models on RAM, VRAM, or both thanks to Llama CPP. RAM will be super slow though, so you need to run things on VRAM as much as possible. In this instance, I have an RTX 3090 with 24 gigs, so I can run whatever the fuck I want, except of course huge models, but that's for another day. Here are my settings. I'm not using repetition penalty, no top P, and 0.2 min P instead. Let's also set top K to something like maybe 12. Let's select Llama 3 instruction template and add a system prompt. You don't have to, but it does have an effect in generation. Let's start with a coding task. Obviously, I'm not qualified enough to try something different, so I'm going to just ask for it to generate a snake game. Now, I already ran this prompt once to test, so it's processing the same thing. Since each generation is unique thanks to seeds, you are unlikely to generate a working code in the first try unless you are working with something like GPT-4. It was quite fast. I actually didn't even fast forward the video. Let's see the generation speed. Yep, it's 60 tokens per second, which is a little bit faster than ChatGPT, I guess. Here is the code. You can just stop and check if it's the same code. It is. I'm not a Python expert, but it looks good. And let's open CMD and try Python vrm.py. And it's working. Let's try WASD. Yep, everything's fine, it's not glitching out. WASD is working well, and we also even have a scoreboard. And when I toss the wall, we get a game over screen. Of course, we are going to try GPT-4o as well. Currently, this model is free, but there's a strict limit of use, and if you are concerned about such things, your data is probably stored somewhere in the OpenAI data vault. Some say this model is awesome, and some say it's much worse than GPT-4. Now let's see how the code works. Here is the GPT-4o's code. Save this. Spoiler alert, I already tried this, and it's working great as well. Okay, maybe not that great because I can close with X button. Let's try Q. Yeah. Okay, well done. What about ChatGPT 3.5? Here I regenerated the prompt with ChatGPT 3.5. Let's copy and paste it here again. And run python gpt-worm.py again. And it's quite shit. I can't control with WASD or arrow keys or anything at all. And it's just going from there to there to there, and nothing's happening. So in summary, GPT-4o wins, Llama 8b wins, GPT 3.5 loses. Of course, like I mentioned, this is one example out of maybe unlimited examples. If I tried this ChatGPT with like 100 times, it will generate working code in 20. Maybe if I run this with Llama 3 8 billion 100 times, it would generate like 40 working code. There's a non-deterministic element in all of this. Lastly, perhaps we should try retrieval. I would love to have a lightweight AI that could go through a random list of people and find someone suitable for my coordination job. Of course, I'm not gonna share company data here, so instead, let's try a list of physicians that I copy and pasted from Wikipedia. Let's ask this question first. According to the list below, who first isolated insulin and who assisted them? Let's check the list to see if this is correct. And in fact, we have the right answer, and it took only a split second. Token processing speed is significantly faster than generation. Usually, large language models tend to deteriorate as the context grows. This is especially the case for multi-turn conversations, which is an unfortunate side effect of attention mechanism. Let's try another question. What did Jonas Salk do? Again, we got the correct answer. This, in my opinion, shows a very decent capability of multi-turn conversation and retrieval. Here we have around 3100 tokens in context, an amount very close to the original Llama 3's context limit of 4K. Lastly, one good thing about Llama 3 is that it's using a different tokenizer, which is more efficient than Mistral and Llama 2. So, your 4K context limit is actually something like 4.5K. Here you can see a 20% difference between two token counts. Mistral is using 500 for the two tokens, while Llama 3 uses 424 for the exact same text. Overall, Llama 3 is great at coding, quite creative and solid in retrieval. This is genuinely cutting-edge technology, and in this human preference ranking from LMSYS, you can see that Llama 3 8 billion Elo score outperforms GPT 3.5 by a significant margin. It's been a while since I started making this video, so I am sure most of the problems with the quantization have been fixed. With a mediocre GPU like RTX 3060 or AMD RX 6800 XT or even ARC A770, you can run a quantized version of this model on your computer. Hell, not even that, if you have some fast RAM like DDR4 or DDR5, you should be able to run a GGF at a reasonable speed like maybe 4 to 5 tokens per second. Here I am using a Q4 GGF loaded on RAM only. Prompt ingestion takes a lot of time, but after the first one I get 6 to 7 tokens per second with DDR4. If you have DDR5, I assume you'll get more than 10 TPS. Before finishing this introduction video, let me talk about the future of Llama 3. At this point, we are due for a giant model with 405 billion parameters. This is unfortunately out of hobbyist range by a significant margin. There is pretty much no way you can locally run it, even at the smallest quantizations. You would need server-level GPUs or really expensive setups with 4 cards. This model is supposed to beat GPT-4 in most or all benchmarks, but we'll see about that. It also doesn't seem like Meta team will release new models in between 70 billion and 8 billion. Still, Llama 3 8 billion is better than Llama 2 70 billion in most benchmarks and real-world use, of course. There are merged models with different parameter counts, but unless trained further, interleaving layers like this doesn't really improve model abilities. There are also higher context, hacked models that are available, but again, the quality is going to be worse. I hope you somewhat liked the video or learned something new, and thank you for watching.